So this video will be on geometric proofs and extra geometry in general. Um, Before I go into the proof that's on this board, I would like to speak about a general strategy to the proofs. Now, whenever we're asked to prove something, we can always set out a plan and write down the plan that we're going to do, what we're going to do. But ultimately, it's organized into statements on the left side and reasons on the right. And the real way to do this in a strategic way is that whatever they give us in the given, we try to see what we can deduce from that given, what we can find out, and how we can use that to prove this statement that line segment AB is parallel to line segment DE. Correct. So before I start though, this video will also be on a little bit of circles as well, because I know the geometry regions love circles, and just line segment and stuff in general that is needed to be gone over. Also remember trapezoid, rhombus, and all those things. Remember what their properties are. Remember how to find the midpoint of one of those. Know the distance formula, which is kind of like this. It's kind of like the square root of changing, I think, x minus the change in y squared or something like that. Also use Pythagorean Theorem, the same thing, you just draw a triangle outward of it. Forgive me if I'm wrong on the distance formula, I didn't memorize it, to be quite honest. I just use Pythagorean Theorem, which is a squared plus b squared plus c squared, right? So you use that if it forms it. No properties of parallelograms, you know that basically the top and bottom are parallel. Also means that they're congruent. General things of lines, they're going to ask you what line is parallel to this line based on slope, what line is perpendicular to this line based on slope as well, but we'll get into that later into this video. Right now we will actually start the proof. I neglected to write certain facts down that I'm going to say. So it says you are given triangle ABC and triangle EDC, and that C is the midpoint of line segment BD and AE. And you just gotta prove that. Okay, so we have a midpoint already. Whatever I said, I'll put like quotes or something and say given. But you might want to write down whatever they give you exactly word for word. And that's like step 1, right? And step 2, we say, well, AC line segment is congruent to line segment EC. And then we say, well, what's the reason for that? Well, if I'm given a midpoint already, what can I tell about a midpoint? Well, a midpoint divides a segment into two congruent line segments. That means that my reason for this should be because the midpoint divides it into two congruent. Right? We can also mark up the diagram. Well, AC over here and EC. We know AC and EC. That should be here. Okay. Now, in order to proceed, I will have to clear this board. When we go over things that are congruent, mark your own diagram in the similar fashion. Okay, so in order to proceed, well, we just got a side, right? So that's one side. This is how we also prove it. We like the patterns, but you can never have angle side. That's reviewed in trigonometry, why you can't have that. It wouldn't make proper sense at all. So we're gonna proceed now. We know also that we can tell from the diagram that there were vertical angles in there, right? So we take those vertical angles and we say, well, statement 3, angle ACB is congruent to angle ECD. Well, why? A reason? Vertical angles are congruent. I might want to write out the entire thing when you do this. I'm just writing very shortly. So that's an angle we just got. Please keep note of what you get from this. Side angles, whatever you get. So we also have another thing from the midpoint. It's line segment BC is congruent to line segment DC. It's the same reason as number 2, the midpoint, right? So we have another side. So, well, what's this going to be then? Our pattern to prove these triangles congruent first. So, well, we say triangle ABC is congruent to triangle EDC. Well, why? Because SAS, or you could say is congruent to SAS, or whatever you want to say. Side angle, side, right? We just got side angle and side. And then 6. Now from here we proceed. And basically CPCTC. Corresponding parts of congruent triangles are congruent, right? So angle A is congruent to angle E. And we just say CPCTC. And then 7. Now this is the final statement. Line segment AB is parallel to DE. Means by, well, what does that mean? Well, it has to be cut by a transversal, right? So that, well, we got that the alternate interior angles are congruent, right? Angle A and angle E, so that means cut by a transversal. Well, then the lines must be parallel. So if cut by transversal, it's parallel. Parallel. And you have to know all these basic things like CP, CTC, SAS, whatever you need to prove that this is congruent to one another. Usually this counts as a part 4 question on the Regents, actually. Probably about 6 points. It's not bad. It's easy points if you know what you're doing. Let's clear this to go on a tangent. Not literally tangent, haha. Anyway, I was talking about circles. So in a different video, I had circles about algebra. This is going to be a bit more about circles and geometry, except I won't go into chords, arcs, whatever you want. I'm not going to really go into that. There's really a diameter, and that's all I really need to go into. I don't need to go into all those weird ways and triangles inside a circle. No thanks. I'll go in that in a different video. This is just going to be about the circle formula. So we have x, that's a bad x minus h squared plus y minus k squared equals r squared. That's the basic formula of it, where the center is h comma k. So in other words, you're always kind of reversing this, the sign of your center, and you plug it in. And that's basically how you get your circle, and that's all you really need to know. You need to know a point slope formula. Y minus y1 is equal to m x minus x1, where m is equal to the slope. So so how did I get the slope? Well, rise over run, right? Like I was saying in the beginning of the calculus video, except it's more like y2 minus y1 over x2 plus x1. It's like the same thing. And then that's how you get your slope, right? But then when I have the slope and I have one point, I take from here, any one point, then I plug it in and I get the full equation along with that intercept. And that's what I need sometimes. Oh, well, in order to find a parallel slope also, it means you have the same slope. You can have a different y-intercept though. So just same slope, keep the slope, and then perpendicular. Say perpendicular is the opposite and reciprocal of that function. Reciprocal is when if I have 1, reciprocal of 1 is, well, x over 1, or whatever you want to call over 1. Then that's basically what you need to know for the kind of algebraic part of geometry. If you know also logic, contrapositive is usually always on there. The converse you need to know. Just know that the contrapositive is basically it takes it and negates both if and then. That's basically what you need to know for now for the geometry regions. If you have any comments, feel free. If you wish to subscribe, subscribe. That is all.